Question number 2 deals with what? Rest and motion. Question number 2, first part deals with when you say an object is at rest. An object is said to be at rest if it does not change its position with time with respect to its surroundings. Example is, there is a wall and a bus. At what distance? Yes, 5 meters. So we make the basic observation. We, in form of a table, time, distance is written as x or s? In the table itself, x or s? X. T is 0, where the bus is 5 meters. After 1 second or 1 hour? 1 second. After 1 second, it is at 5 meters. After 2 seconds, it is at 5 meters. 3 seconds, it is at 5 meters. So, whenever you ask, this bus is at 5 meters from the wall. So, we say it is at a rest. How to plot its xt graph? X along y-axis and time along x-axis. T is equal to 0, 1, 2, 3. Let this be 5 meters. When t is 0, x is equal to what? T is equal to 0, x is 5. T is equal to 1, x is 2, 3, 5. So, all the time it is at a constant distance. What is the velocity of this particle? This is the position. We have discussed, through this we have discussed the position of the particle. Velocity or speed of the particle v is equal to dt of x. X remains same. Differentiation of a constant is purpose pata lag gaya 0 chapter da. So, exactly below this, if you plot a velocity or speed graph, yes, speed will come out to what? 0. Speed is 0. 3 minutes to draw. Three minutes. B part deals with what? Motion. When you say the object is in motion, let us see. Again, first part is photograph. This part is photograph. This is graph. This also graph for velocity. At t is equal to 0, vehicle is at origin, x is equal to 0. After 1 second, you click the photograph and the vehicle is at 1 meter. After 2 seconds, you again have a photograph and now it has covered 1 meter plus 1 meter, 2 meters. This is photograph at t is equal to 0 second. This is photograph at 1 second. This is photograph at 2 seconds. And at 3 seconds, it has further covered 1 meter more. At t is equal to 0, where the particle is? At 1 second, it is what distance from the wall? At 2 seconds, it is. At 3 seconds, we have to plot xt graph. When t is 0, x is, t is 1, x is, t is 2, x is, t is 3, x is. So it is a straight line passing through origin. What is the equation for this? Anyone? X and t relationship. X is equal to t. Then the second part, you have to draw velocity graph. Velocity is equal to what? dt of x. X is equal to what? T. dt of t is what? 1. V is equal to 1 meter per second. Velocity anytime the value is 1 meter per second. So how do you find velocity from the graph itself? Slope. Here this angle is, yes, value of this angle is 45 degree. Tangent 45 is what? 1. So you can find velocity or slope by directly having value for tangent 45. Tangent 45 is equal to what? 1. So by differentiation method you can come out with the same. Time 3 minutes. 3 minutes. Then the issue is rest and motion are relative. Is it true? When you say relative means varies from person to person. So the example given here is, this frame platform, train is moving at what speed? Yes, 60 kilometer per hour. There are 2 passengers. No, there is 1 passenger. Yes, Rinto. Rinto is inside. Another one, another observer, Chintu, is outside. So this is, we say, is ideal observer because it is in a frame where the speed is 0. So the person who is on the platform, we say that is the true or real observer. So it is this observer is at rest platform. So we ask the question, Chintu ne puchha question, what is the speed of the train? He says 60 km an hour. What is the speed of Rinto? He says 60 km per hour. And there is a waiter inside. Again, ask Chintu, what is the speed of the waiter? He says 60 km per hour. Suppose waiter is at rest. Now we ask Rintu about the status of the waiter. Rintu pucha ki question is, what is the speed of the waiter? He says he is at a rest. Why? Because both are moving with what speed? 60 km per hour. So common observation, you are moving in a train, you have a co-passenger, you are talking to the person, you hand over water, exchange goods. Because for you, that fellow is at a rest. But actually both of you are moving with the speed of the train, say 60 km an hour. So it depends on the observer. The observer inside says waiter is at rest, and observer outside says the same waiter is moving with what speed? 60 km per hour. That is why rest and motion are relative. And you have number of questions on relative velocity. We'll discuss in detail velocity of one as seen by other. 2 minutes to write. Rest and motion are relative.